Single inheritance means one class the child gets features from exactly one other class the parent. Imagine a child receiving toys from a single parent. The child can play with all the toys the parent owned and can also add new toys of its own. Syntax: Python class dog animals. Java class dog extends animal. C++ class dog public animal. Basic implementation. Class animal define method speak print generic sound. Class dog inherits from animal define method speak print woof exclamation mark. Pet equals new dog. Pet dot speak prints woof. Dog automatically has everything animal has the speak method, unless it decides to replace it with its own version. Multi-level inheritance is a chain of single inheritance steps like a family tree with a grandparent, parent, and child. The child gets features from the parent which itself got features from the grandparent. Syntax Python example. Class vehicle colon. Indent def move open parenthesis self close parenthesis colon. Indent print open single quote moving close single quote. Blank line. Class car open parenthesis vehicle close parenthesis colon. Indent def honk open parenthesis self close parenthesis colon. Indent print open single quote beep exclamation mark close single quote. Blank line. Class sports car open parenthesis car close parenthesis colon. Indent def accelerate open parenthesis self close parenthesis colon. Indent print open single quote zoom exclamation mark close single quote. Blank line. My underscore car equals sports car open parenthesis close parenthesis. My underscore car dot move open parenthesis close parenthesis. My underscore car dot honk open parenthesis close parenthesis. My underscore car dot accelerate open parenthesis close parenthesis. In Java or C++, the same idea uses extends or colon with multiple public bases. Each level builds on the previous one, just like adding new rooms to a house built on an existing foundation. Explanation. When objects are created or destroyed, constructors and destructors run in a specific order, like building or tearing down a Lego tower. Construction order. Number 1, the most base top class constructor runs first. Number 2, then the next level's constructor, and so on until the most derived class runs last. Destruction order. Number 1, the most derived class destructor runs first. Number 2, then its parent's destructor, and so on back up to the base class. Example C++. Include IAStream. Define class animal with a public default constructor that outputs animal ctor and a virtual destructor that outputs animal detour. Define class dog that inherits publicly from animal with a public constructor that outputs dog ctor and a destructor that outputs dog detour. In main, create a dog object named D. This prints animal ctor followed by dog ctor. When main ends, the destructors run, printing dog detour then animal detour. For a 3-level chain grandparent to parent to child, the output would show 3 constructors in order and 3 destructors in reverse order, just like stacking 3 blocks then removing them one by one. Explanation. Method overriding lets a child class replace a parent's behavior with its own, similar to a child learning to sing a different song than the parent sang. The child can still call the parent's version using super Python or base/super Java C#. This enables polymorphism. A variable typed as the base class can hold any derived object, and the right method runs automatically. Python example. A class named animal with a method speak that prints 3 question marks. A class named dog inherits from animal and its speak method prints woof exclamation mark. A class named cat inherits from animal and its speak method prints meow exclamation mark. A function called makeItSpeak takes a parameter of type animal and calls a .speak. Then makeItSpeak is called with a new dog instance which prints woof exclamation mark, and then with a new cat instance which prints meow exclamation mark. Java example with super. A class named animal with a speak method that prints 3 question marks. A class named dog extends animal and overrides the speak method. Inside that method it calls super.speak, which would invoke animal's version if we want, and then it prints woof exclamation mark. In a multi-level chain, each level can override and still call super.speak to add its own twist, forming a layered song where each generation adds a new verse. Explanation. Access specifiers decide who can see a class member, much like rooms in a house. Some are open to everyone, some are only for family, and some are private to the owner. Public, anyone can use it, front yard. Protected, only the class itself and its children can use it, family room. Private, only the class that defined it can use it, personal diary. When a class inherits, public members stay public for everyone. Protected members stay protected. Children can see them, but outside code cannot. Private members are not directly visible to children. They are hidden, but the child can still use public or protected functions of the parent that internally work with the private data. C++ example. Class base with private integer secret equals 42, protected integer half secret equals 21, public integer open equals 7. Class derived inherits publicly from base defines method show. Inside show there is a commented out secret with error not visible. Integer A equals half secret, OK protected, integer B equals open, OK public. Python does not enforce access, but the convention underscore name for protected and double underscore name for private mangled follows the same idea. Explanation. Design-wise, use inheritance when a relationship truly exists. A dog is an animal. Single inheritance keeps things simple and easy to read. Multi-level inheritance adds depth. Each extra level adds a small lookup cost because the runtime has to walk up the chain to find a method. The cost is O of depth, linear with the number of levels, which is usually negligible for a handful of levels, but can become noticeable if you create very deep hierarchies, for example 20+ levels. When to prefer composition. If the relationship is more has a car has an engine composition, embedding an engine object inside car avoids deep inheritance and makes the code more flexible. Keep inheritance depth under 4 to 5 levels for readability. Cache frequently used behaviors in the most derived class if method dispatch overhead matters, for example real-time game loops. Java code example, class widget defines a draw method. Class button extends widget and overrides the draw method. Class image button extends button and overrides the draw method. When the UI thread calls widget.draw, the runtime checks at most 3 levels, a trivial cost compared to the actual pixel drawing work. However, if you kept adding super button, mega button, ultra button, and so on, you would make the code harder to maintain without gaining useful behavior. So limit depth, favor composition for reusable parts, and remember that inheritance is a tool for sharing common, is a traits rather than a way to build infinitely tall class towers.